Hello everyone, welcome back to the next video. Today we are going to solve a very interesting problem which was asked in Google on 6th of August in 2024. The name of the problem is minimizing the amplitude of the array. So let's dive into it. What's the question? The question is we have given an array A and we need to find the minimum amplitude of the array by changing up to 3 elements. What do we mean by amplitude? Amplitude basically means the difference of the largest element of the array and the smallest of element of the array. Let's understand it with an example. So here is an example which is given to us. The input array is -1, 3, -1, 8, 5, 4. So let's compute the amplitude of this array. It will be 8 minus -1, which will be equal to 9. Okay. Is this the minimum amplitude? No. We have given a condition that we can change up to 3 elements. Let's try doing it. Let's change the minimum 2 elements, which is -1 and -1. Let's change it to 3. Okay. Both the elements will become 3. And let's change the largest element, which is 8. And let's change it to 5. Okay. So the new array will become this 3, 3, 3, 4, 5, 5. Now let's compute the amplitude. The amplitude will be 5 minus 3, which is equal to 2. This is the minimum amplitude we can get from this array. Okay. Now to change the minimum 3 elements, we can have 3 cases for it. What will be the cases that we will be using to change the amplitude? The first one is we can change the 3 smallest elements of the array and make it equal to the 4th largest element. Okay. Here in this array, we can see these 3 smallest elements are -1, -1 and 3. And we can change it to the 4, which is the 4th largest element of the array. Okay. So we can do this. The next condition is changing 2 smallest elements and 1 largest element. We can change the first 2 smallest elements that we did here in this example. We changed the -1, -1 and 1 largest element, which is the 8. We changed the -1, -1 to the 3rd smallest element, right? And we changed the largest element to the 2nd largest element so that we can minimize the amplitude. The third condition will be changing the first smallest element and 2 largest element. So we will change the first smallest element to the next smallest element, right? To the second smallest element. And we will change the 2 largest element to the 3rd largest element to minimize the amplitude. Okay. And the fourth condition could be we can change the 3 largest elements and we can make them equal to the 4th largest element. Okay. In the end, we will be computing minimum of these 4 conditions to get the minimum amplitude. Okay. Yeah. So let's move on to the approach. What approach we will be using? First of all, we will be using the heaps because to solve the problem in O of n complexity, we need to use heaps. What we are doing, we are only computing the 4 largest and 4 smallest elements, right? We do not need to iterate throughout the array. We do not need to have a whole array sorted. We only need 3 largest elements, 4 largest elements and 4 smallest elements. That's why we are using heap. If we used sorting arrays technique in it, that will increase our time complexity to O of n log n. Okay. We have another optimized approach, which is using the heap that can solve the problem in O of n time complexity. So we will be using max heap to store these 4 smallest element, and we will be using a minimum heap to store 4 largest elements. Let's move on to the code now. Let's move on to the writing the code of the problem. First of all, we will create a variable. Okay, let me put it here. Firstly, we have created a variable int n, which is equal to the length of the given array. Okay. Next, we will check by an if condition if our array has length equal to or less than 4 or not. If this is true, we will simply return 0 because we already know that we can change at most three variables in our three elements in our problem, right? So if the array has less than 4 elements or equal to 4 elements, we can make all the elements equal to each other, and our amplitude will be 0 in this case, right? Next, we will be making a max heap. Let me write the code for it. This is the code for the max heap. So we are using a priority queue, which is a minimum heap by default in Java. However, we want a max heap to store the 4 smallest elements of the array efficiently. So to achieve this, we use this collections.reverse order, which makes the priority queue behave as a max heap, because it means that the largest element is always at the top of the priority queue. It will allow us to efficiently remove the largest elements whenever the heap size exceeds 4. Okay, that's why we are using this collections.reverse order. Next, we will be making a minimum heap. Okay, and we will use this minimum heap to store the 4 largest elements of the array. Okay, next we will use a for loop. Let me write it here. Yes, so we are using this for loop to iterate through the array. We are adding each element to the max heap. If the size exceeds 4, we remove the largest element, ensuring we only keep the smallest 4 elements in the heap. Okay. We are also doing the same for the minimum heap. We are trying to store the 4 largest element of the array, and whenever the size exceeds 4, we are removing the elements from it so that we can store the 4 largest elements. Okay. Next, we will be storing. No, we will not store. We will convert the heaps to the array list. Okay. We initialize the array list, smallest and largest. And after that, we will store the values from our heaps into these array lists. Okay. So we have introduced smallest and largest array list. In the smallest array list, it will store the 4 smallest elements, and in the largest array list, it will store the 4 largest elements. So we are simply adding the max heap numbers. We know that max heap contains the 4 smallest elements, so we are simply adding the max heap elements to the smallest array list. Simply, we are adding the minimum heap elements to the largest array list. Okay. After that, we will sort both the arrays. Okay, we will sort both the arrays in ascending order. So here is the code for sorting the smallest and the largest array. After that, we will write our conditions. Okay, we have sorted the array, we have stored the 4th and largest element. What's left? We need to compute the amplitude, right? So to compute the amplitude, we have these 4 conditions. These 4 conditions are similar to the 4 conditions that I have explained to you earlier. Okay, and we are computing the minimum of these 4 conditions so that we can get the minimum amplitude. Let's understand it with an example. The first condition says in the largest array get 0, means, and it minuses the smallest integer which is in the smallest array, which is at the index 0. What does it mean? It is uh, it is the same condition, this one, which says that we need to change the 3 smallest uh, array, 3 smallest elements, and make it to the equal to the 4th largest element. Okay, so what is it doing? It is getting the element which is in the largest array, which is at index 0. It means, let's see this example. I have sorted the arrays, and I have also make the arrays. Like in the smallest array, we have the numbers -1, 3, and 4. These are the smallest number in the given input. And we have the largest array, which has 3, 4, 5, 8. These are the 4 largest input in the array. Okay. So we are getting the element which is at 0. So in largest, we have the element 3, and we are getting all the three elements of the smallest array, which are -1, -1, and 3. And we are making it equal to the fourth largest element, which is 3. So if we made all these three elements equal to 3, what will be the amplitude? It will be 8 minus 3, which is equal to 5. Okay. So this is what this first line is doing. The second line means largest get 1 minus smallest get 1. It is basically based on this second condition, which is we need to change the two smallest element. We need to make the two smallest element equal to the third smallest element. And we need to change the one largest element. We will be changing the largest element and will make it equal to the second largest element. Okay. And in the end, we will compute minimum of these two conditions. The next third condition is we need to change the one smallest element and two largest element. What we will be doing, we will make the first smallest element equal to the second smallest element, and we will change the last two largest element and we will make them equal to the third largest element. Okay, so this is what this third condition is doing. And in the fourth condition, it is simply changing the last three largest elements. We will make all the last three largest elements equal to the fourth largest elements, right? So these are the four conditions that we have used to compute the minimum amplitude. Let's try to run this code. Okay, it's done. Let's check on console whether our output is correct or not. Yes, the output is right. These are the two examples that we used. So the output for the first array should be equal to 2. It is giving the right answer. And the output for the next array should be equal to 0. And it is giving the right answer. You can also check this code for other examples too by on your own. So I hope that you understand this problem, right? We solved the problem in big O of n complexity, and the problem has a constant time complexity too, because we are only storing four elements of an array in this problem. So this is about the problem. I hope you understand it. And let's meet in the next video with another problem and another solution. Bye.